so we'll start with the review for the exam 2. Again, chapter 4 and 5 included true false questions. Chapter 6, 10, 11, they're part of your exam solving problems. 12, no, it's not included. 12 is not part of your exam. So let's start with them one by one. Let's start with multiple choices. What will be a muscle fiber reaches peak tension relatively slow? That's from chapter 6, right? I'm going to focus on true false, true false from 4 and 5. If I want you to fill in the blank, it will be from 6. That's usually what I do. So which one do you think reaches peak tension relatively slowly? Yeah, you have fast twitch and you have slow twitch, correct? We good with that? Now, what is a role played by a muscle to stabilize a body part against some other force? So which muscle? What do you call that muscle? From the name, right? We have the agonist and antagonist, and we have the stabilizer muscles, neutralizer muscles, right? So make this movement steady, right? So stabilizing body parts, that's stabilizing, but neutralizing is actually, it's just like eliminating the effect of another muscle to neutralize that effect, right? Okay, what about a pattern of eccentric contraction followed immediately by concentric contraction? What is that called? You know, one of the slides that you have the shortening contraction, jump, and then you go out front, but it has something else, shortening something, right? Called the cycle, shortening, lengthening cycle. It has to shorten and then elongation. So that's the key thing. That thing. Yeah, you can go back to the shortening something, shortening contraction cycle, something like that. But I will get it. Stretch, shortening, stretch. So you stretch and then you shorten it again. So the slow twitch, stabilizer, and then you have the stretch short cycle. Stretch shortening cycle. We good? Makes sense? Okay, so let's see how we're going to be solving problems together. So the first problem we'd like to solve is this. How much force is exerted by the tendon of a pinnated muscle when the tension in the fiber is 100 Newton, given that we have different angles? You remember we talked about the pination angle, right? Which is the angle of the fiber along the axis of the muscle, right? Now, where do you think the force, on the tension will be on the muscle? Which direction would that be? On the tendon, by the way. So where are the tendons, right? Correct? It's connecting the muscles to the bone, right? Now, so what I care about is FT, so this is your FT, right? The force. And I have an angle of pination. That's the angle of pination. I care about, you can decompose force into two axes, correct? So you can do one on the x-axis and one on the y-axis. Sorry, one long and one perpendicular, correct? So if I gave you this angle to be 40, what is going to be the force along, the tendons? It's going to be the force, which is 100, multiplied by cosine or sine 40. Cosine, right? So the force here, because that is the angle between the force and the axis. So this is going to be, the first one is going to be 100 cosine 40. How much is that? So that's the 40. Remember, we care about the force along, that's on the tendon. So 76. Now here's the thing, 0.6. How many significant figures are those? 3. The unit should be what? Don't forget that in the exam. So you need to have all your numbers in 3 significant figures, and you need to have a unit in the exam. And now, how about the F if it's 60? So this is your force, right? F 100. This is the angle between the force and the axis that I care about. I don't care about this axis. And we always, if you're looking at the projection or decomposing this force into two forces, one in that axis, one in the other axis, if it's between the axis of interest and your line of action, that's cosine. So 100 cosine the angle will give you that force that you want from there, and the line of action of the force. So for example, what if I told you I have something like this? So let's say we have this force, right? But I gave you this angle to be, let's say 60, right? Along this axis, that's cosine. Along that axis, that's sine. So let's say this is 20, that's 60 degrees. This is going to be 20 cosine 60, right? And this is going to be 20 sine 60. So if you want to resolve, that's resolve a force into two components, perpendicular components. If you have an angle, the angle, whichever axis with that angle, that's cosine. That's sine. That's true. That's correct. So that's what we did here, and with this pination, the muscle. That's resolving a force along two axes, two perpendicular axes. So if the angle is 60 now, alpha, what do we do? It's the same thing on the same axis, right? So it's going to be 100 cosine 60. How much is that? 50? No. I don't want you to put another, you can do this 50.0 newtons. That's to be accurate. But if it's, just a number, 50, it doesn't matter. Yeah, but I don't want you to write 76.61, for example. That's for significant figures. We don't need that. Okay, what if it's 80? 100 cosine 80, right? Correct. So 100 cosine 80, and how much is that? 17.4. Don't forget newtons, right? That's our force. That's our force. Now, here's another thing. The larger the angle of pennation, do you think it's harder on the tendons or, easier on the tendon to deal with? The larger means the smaller forces in the tendon, which means that that's less damage if we are exceeding that force. So the angle of pennation in humans, it's usually actually, it's a huge variety actually between different people. But the larger of the angle of pennation, the smaller the force that is affecting the tendons, which is safer on them. Does it make sense how we look at that? Okay, any questions about this question? We good? Alrighty, next one. What do we have? How much torque is produced at the elbow? So the elbow joint, we're looking at the elbow joint, by the biceps brachii inserting at an angle of 60 degrees on the radius when the tension in the muscle is 400 newtons. So the muscle is giving 400 newtons, but we have an angle of 60 degrees. And also the other thing is the biceps is attached to the bone, to the 3 centimeters away from the joint, from the elbow, so which is the center of rotation. So let me give you 4 minutes to think about this, and then we'll solve it together. Let's do it 5 minutes, but this is important because we need to be able to draw the free body diagram first and then find the torque. The torque is the force multiplied by the distance, but it has to be a perpendicular force, correct? Yeah, that's the significant force. Unless it's 346.5, you need to round one, right? I'm not going to be that picky on those things, but it's important to... Oh, what's her name? The lady that from Agility. She replied to me and she said she's going to send you we are also building a relationship with Spire. Do you know Spire? Facility, the rehabilitation facility. Okay, do you want to start doing it together? So here's the deal. I'm going to do it here on the screen. So what we want to do, first of all, our torque, I told you, we don't want to call it anymore as a moment. We would like to call it torque. So it's T, right? It's going to be the force multiplied by the perpendicular distance. That's it. That's our torque. So what are you going to do? This force here, it comes with an angle. So this is the point of rotation, and we have an angle. So what I would like to do, I would like to break FM, the 400, into 2 components. One like this, and the other one goes this way. I'm resolving the 400 newtons in 2 forces. So where is the 60 degrees? Is between the line of action and the x-axis. So that's going to be 400 cosine 60. Correct? The one here is going to be 400 sine 60. Do you agree? We good with that? Which one is the one that we would like to, that's going to create the torque? Remember, this is your this is your joint. Which one is going, if you have a force that is passing through the joint, the distance is 0, which means there's no torque. So the thing that's going to create the rotation is this one, right? Around the joint. So that's my force. How much is the distance between here and there? The question is saying it's 3 centimeters. You can't put distances with centimeters or millimeters. You need to convert them to meters, Newton meters, correct? So 3 centimeters, how many meters is this? Yeah, you divide by 100, so it's 0.03 meters. Now, I have my force. The force is 400 sine 60, right? And you multiply it by the distance, which is 0.03. And that's how much torque actually is produced by the biceps around the joint, the elbow, the joint. How much is that? 10.4 Newton meters. Now, don't forget this. For the units, if you have 2 different units, you need to put a dot between them, right? Newton dot meter, and that is your moment torque. The other thing that you need to add, is it clockwise or counterclockwise? Look at the picture that you have. You can say this is counterclockwise, or just you can draw the line, because that's important in doing the torque, right? Does it make sense? Yes, because that's the complement. So this is the complement. So that's 30, right? Now, if you would like to use the 30, where is the cosine? This is going to be the cosine, because that's where the axis and the line of action angle is between the two, right? You're right, absolutely right. Was that? So look at the joint, right? See this force is tending, this is tending to rotate that way. You remember the right hand rule. You put the thumb coming out from the axis of rotation and look at the force where the force is moving. That's how you follow. Yes, right? And actually, see the thumb axis is actually where, if there is a screw there, the thumb is pointing how the force is pulling. So you have a torque, but it's pulling out. Are we good with that? Cool. Next question. Now, how much tension may be developed in muscles with the following cross-sectional area? Now, remember we said the larger the cross-sectional area, the stronger the muscle, right? So if I said to you, well, we have these muscles with 4 centimeters square, 10 centimeters square, and 12 centimeters square, how much tension? Now, there is a rule. I didn't add it here, but just for you to pay attention to it. The rule is saying that for each, if we have a healthy subject, the healthy subject will produce 90 newtons, so that's the rule. You will be producing 90 newtons for each centimeter square. That is a rule if a subject is healthy. So if I told you I have 4 centimeters square, 10 and 12, how much force, how can you calculate the force? Yes, if in the exam I will put it for you. I just want to wanted you to pay attention to it, because sometimes with physiological entities you need to have something from the experimental data to add it to your calculations. So in the exam, yeah, I'll be giving that to you, but you should remember it by now, right? It's 90 newtons, bless you, 90 newtons per centimeter square. Yes, yeah, you can. Values and constants you can add. It's just solving problems is not. So if you want to do this, how many? If you have 4 centimeters, how do you find how much force? What do you do? So you do this multiplication. You say the force equals 90 newtons per centimeter square multiplied by 4 centimeters square, right? I like to put the units because it makes things easy for me to cancel. So this goes with that, right? And 4 by 9, 360 newtons. Makes sense, right? So if you have a muscle fiber that is 4 centimeter, the muscle itself have 4 centimeters square as a cross-sectional area, it will produce 360. How much is 90 multiplied by 10? How much is that? 900 newtons. And F3, I should know that. That is 90 by 12. How much is that? How much? 1080. Now, here's the thing. 1080 is not the one that we should be adding. So what you have to do is this. 1.1 kilonewton. Because here's the thing. So it's 1.0. Oh, you're right. You're absolutely, because that's three significant figures. You're right. This is 3 6 figures. If you have anything in thousand, don't put it without the K, kilonewtons. Anything when you reach that 1K, you use Ks. You don't put that thousand. No, but this is 4 significant figures. The 1080 is 4. It's 4 significant figures. If you have a decimal, but if you don't have a decimal, it should count. The rule of thumb is if it's in thousands, you need to use the kilonewtons. Yeah, and then you do it from there. Because we would like to use the kilonewtons, mega and giganewton with that thing on your calculations. Okay, makes sense? We good? But I will double check. I don't remember that if the last digit is 0, that does not count. I don't remember. I will double check. But I will check it. Okay, now another question. So we have a swimmer orients herself perpendicular to the parallel banks. So this is the river. You have bank 1 and bank 2. It's going from this point to that point. If the swimmer velocity is 2 meters per second and the velocity of the current is 0.5 meters per second, what will be her resultant velocity? Also, how far will she actually have to swim to get to the other side of the bank if the distance between the two is 50 meters? So let's get another 5 minutes and see if you can check that thing. We good? The resultant? Okay, so if you would like to, so this is the diagram of the problem, right? And it's giving us things easier. So we know that I would like to find R. And if you use the Pythagorean formula, so R square, right, is going to be 2 square plus 0.5 square, right? So you need to make sure that you're drawing this correctly. Remember, 2 meters per second is the speed of the lady, the swimmer, and that's a vector. So that should be directed in one direction. And you assume that the current is going to that direction. That's 0.5 meters per second. So R is this one. So how much is this? So if you want to find R, it's going to be the square root of 2 square plus 0.5 square. How much is that? 2.06 meters per second. Can we confirm? Perfect. Now, so you got this, correct? Now, here's the thing. The other question, we would like to find how far. And that is, so if you want to do the same thing, she's going to be swimming this way, right? Correct? Because the water is going to push her away. Now, this angle, alpha, should be the same as this angle because that's the displacement. So if you find this angle here, you will find the same angle, the alpha on the other side. So what do? We can find, how do you find alpha? Tan inverse? What over what? Over 2. How much is that? 14 degrees, right? That's 14 degrees. It's 14 degrees. So this one is also 14 degrees, right? So if I have 14 degrees, I would like to find D, the big D here. So that's a triangle. I have D and the 50. So I can say that, well, if you look at the formula that we did before, this distance here is going to be D cosine 14, right? So that's the distance, right? Let's say this is a vector, and it's called D. Now this one here, the projection or the component that is with the angle, the small one, is going to be D multiplied by cosine 14. So 50, I can say that 50 equals D cosine 14. Then remember, those are vector displacements, and then just velocity and position. So D equals 50 over divided by cosine 14. How much is that? How much again? 51.5. Now, what is that? Meters. Don't forget that meters. Yep, checks. Are we good? Alrighty, next one. Let's go quickly with those. We have a soccer player. A ball is rolling down the field. Now, at time equals 0, the ball has an instantaneous velocity equals 4 meters per second. So at time equals 0, at the beginning, I have a velocity of 4.4 meters per second. If the acceleration of the ball is constant at minus 0.3, what does that mean? Minus. Decelerating is going to stop at the end, right? How long it will take before it do the complete stop? Let's take 2 minutes. Think about this one. Remember, this is linear, so your acceleration is the rate of change of the velocity with respect to time, right? Anyone was able to get that? How much is that? 13.3 seconds. Confirm? So it's very simple. So the acceleration A equals V2 minus V1 over T, correct? Now V2 is going to be 0 because that's going to be our final velocity, right? Minus V1, which is 4, divided by time, which I don't know, and my acceleration is minus 0.3, right? Rearrange things around, so that's going to be minus T equals minus 4 divided by 0.3 minus 0.3, and that's going to give us 13.3 seconds. You good? Any questions? Okay, that's simple. Now, let's go into a big one. Now, this is another problem that has to do with solving the equations of motion. Remember, we have two, you can break any problem into vertical and horizontal components, right? To solve them. Now, here's a question. We have a basketball passed through the hoop, even though it barely cleared the hand of player B. So this almost touching. Who attempt to block it? Neglect the size of the ball, find the VA of its initial velocity and the height of the ball when it passes over player B. Now, this is two problems in one. We would like to start with a problem that has the largest number of known values. So forget B, forget this player. Let's find out VA and focus on the distance between A and C. Does it make sense? Between A and C. Forget the one in the middle, the guy in the middle. To form these equations, we will start by forming horizontally. So let's do it this way. Focus on AC path. We're good? That's what I want to focus on. So horizontally and vertically, we have two things that can go at the same time, right? Horizontally, do I have acceleration in the x-axis? No, this is a projectile problem. So what do we do? Remember we said that x final equals x initial plus vx multiplied by time. Now, here's a tricky thing. You need to put that t between A and C, right? I'm going from A to C, all the way there. Now, Vx, what is Vx? This is your Vx, and this is your Vy, correct? So Vx, what Vx equals? Va cosine 30. Do we agree? Does it make sense? Now, Vy equals Va, which is unknown, sine 30. Are we good with these two? Okay, now, what is my x final? 30, 25 plus 5. I'm going from A to C, right? From A to C. I have 25 plus 5, that's 30. So that's 30 equals, what is my x initial? No. Oh, sorry. Yes, you're right. It's 0. Of course it's 0. It's just, he's shooting it. Vx will going to be 0. Now, that's 0 plus Vx when it's flying until that last point, that's going to be Va cosine 30, right? So you put Va cosine 30 and then multiplied by TAC. We good? Makes sense? Now, how many unknowns do I have in this form, in this equation? 2. I have TAC and VA. I needed another equation to solve it, right? So, the vertical component, we're going to use the y, correct? Now, I have an acceleration. The acceleration is the gravity. So, the formula that I'm going to use is the y final equals y initial plus VYT, correct? Minus half, because I have the gravity, right? GTAC square. Does that make sense? Because in the vertical axis I do have acceleration, so I need to add that there. Now, what is my y final? 10. Remember, here's the tricky thing. Everything in this question is feet, correct? So it's 10. What is my y initial? 7. What is my vy? It's VA sine 30, right? TAC, correct? Minus half. What is acceleration in feet per second square? 32.2. TA square, AC square, right? So now you have another equation. How many unknowns do I have here? 2, right? Right? So I can do substitution. You can, let's say, you can find A in term of TAC and substitute there and find the other one. And at the end of your calculations, you will end up with finding 2 values, right? If you do the substitution, you will end up with VA equals and TAC equals, right? Correct? Now, in the exam, I'm going to get you something that is simpler to do the to find the solution for it. But if you do this calculation, your velocity here is going to be 36.7 feet per second, right? And the time is 0.943, which is 0.4, yeah, that's seconds, right? I might ask you in the exam, if I give you something like this incomplete, I will tell you, just formulate the equations of motion, don't solve them. I did this before, but you need to make sure that everything's correct in the formula. You'll get this, you'll get the diagram and the problem. No. If I always like to give you schematic to make things easier for you. I want you to visualize it. Does it make sense? And here's, by the way, make sure that you know that this is part 1. We still did part 1 of the problem. Now part 2, I found VA and TAC. Now I would like to find the height, h, for player B. So what I will do, let me erase all of this. Yeah, so don't forget that it's 2 parts. I will do the first part with the one that has the largest number of known values. And then I will do the next one, the second one, which is the point from A to B, correct? So here's what I'm going to do. I'm going to be solving now from A to B. So that's AB now. Same thing, I need to construct the equations of motion for the horizontal and the vertical. So let's do the horizontal. Again, x final equals x initial. I don't have acceleration, right? Plus vxt. Now, what is my t now here? AB, correct? It's between A and B now. So what do? What is my x final? How much is x final? 25. X initial, 0. I'm starting from 0. Plus, what is Vx? It's VA, but I know what VA is, right? How much is VA? So you say 36.7 multiplied by cosine 30 multiplied by TAB, correct? How many unknowns do I have here? 1. I can find TAB, correct? You get TAB. So if you do the calculation, TAB equals, how much does that equal? Yeah, so it's 0.787 seconds. Yeah, Alyssa, if it's 7.8, that will scare me. Because it's taking 0.9 seconds to go there. And then 0.7. Okay, now vertically, what do we do? Same thing. Y final equals Y initial plus Vy TAB minus half 32.2, right? TAB square. Now, Y final is B, right? Because I don't know that value, correct? Y initial is 7. I know Vy because it is going to be VA multiplied by sine 30. So plus 36.7 sine 30 multiplied. How much is TAB? We have that. 0.787 minus half 32.2 multiplied by 0.787 square. How many unknowns do I have here? 1. I get B immediately. Because I substituted TAB and the other values, the VA. And if you did that, how much would that be? Yeah, 8.77, 11.5. There's something wrong. Now, 11.5 what? Feet, right? We good? I'm going to put this video. Oh, the practice for the exam. Same, all the questions here, but different numbers. So the same thing, but different numbers. Same question. Yeah, different numbers. Okay. That's what it is. Yes. And make sure that when you formulate the equations, you don't make mistakes. Because that's the key, formulating the equations of motion in the x and the y. Yeah, we're going to do them quickly. Okay, so guys, are we good with this one? So let me show you the other one. They quickly to go through. So if you have a golf club swung an average angular acceleration, this is your A, right? 1.5 rad. What is the angular velocity? If I gave you the time to be 0.8. So if you do these things, the question here, remember, angular acceleration equals the rate of change of the angular velocities. Oh, if it's if this is that's the level of difficulty, I will tell you just construct the equations of motion. Just don't fill the TAB or that. It will be way much simpler if I want to do that. The only thing that I care about is formulating the equations of motion. Can you formulate in the x and the y directions and make sure that which one has the acceleration and the velocity with the angle, Okay, so alpha is W2 minus W1 over time, correct? That's the acceleration. So what do we have here? Swung at an average angle acceleration of 1.5. I have that, right? What is the angular velocity of the club when it strikes of the ball? So I have the time, which is 0.8. Now we need to find the velocity, correct? So that's W2, and W1 usually you start from 0, correct? Right? And then you have one unknown to find. So you can say that W2, the angular velocity, is 1.5 multiplied by 0.8. Now here's the tricky part. Make sure that you provide your answers in rad. This is rad per second square. Oh, rad per second, sorry. Correct? How much is that? 1.2. Now, if you want to do it degrees base unit, so degrees per second, so there is the formula that you can do that. You remember that 57, right? 57.3 degrees is 1 rad, right? And you do the 1.2 rad. So if that's so 1.2 rad, you multiply it by 57.3 divided by 1. That will give you with how much in degrees per second. And if you do the calculation, that's 68.8 degrees per second, right? We good? Okay with that? Okay, now the other one is also simple. Remember that the formula for the linear velocity from angular velocity, always we have V equals RW, right? Correct? So I have the R's and I have the V, that W. You can find the linear velocity from the 20s and the 40 by just multiplying 20 multiplied by 30 and 40 multiplied by 30. This is converting angular velocity into a linear velocity by just multiplying the radius, right? Remember we said that the further you are away from the center of rotation, the faster the velocity going to be. So that's going to be for V1 equals to 20 multiplied by 30, and V2 equals 40 multiplied by 30. It's all, so that's centimeters, right? Yeah, which is 0.3 and 0.4. That's correct. You're right. Make sense? So you multiply it by, so because 20 centimeters, 0.2 meters multiplied by 30, and 0.4 multiplied by 30. We good with these? So that's 6 meters per second, and that's 12. We have 5 minutes. So quickly, or 2 minutes. Quickly for the last one. See, we have this lady. She is pitching along 0.65 seconds, and the pitch arm is 0.7 meters, and we have a speed of 20 meters per second. Now this is we need to the acceleration, right? Remember we have two accelerations, correct? So we have the AT and the A perpendicular, So how would you do the AT? What is the formula for AT? V2 minus V1 over the time, and the A radial is V squared over R, right? Correct? So here we have, so what do we have? We are when the tangential ball is 20 meters per second, so that is our final. So that's 20 minus 0, because she starts from 0, and over the time, which is 0.65, right? And if you do this, you will get 30.8 meters per second square. That's the tangential velocity, right? Now, for the radial, it's the same thing. We are leaving at this point with that same speed. So that's going to be 20 square. And how much is the radial, which is the pitch arm? That is 0.7, correct? And that, if you do the calculations, that 571 meters per second square. Now, they're asking us to find the magnitude of the total acceleration. which means you take A, you say square root 30.8 square plus 571 square. Makes sense? Because each one of them is perpendicular to the other, and you do the Pythagorean rule, and then you take the square root of each one of those. And if you did the same, that thing going to be 572 meters per second square. Make sense? Yeah, This is all the entire content of it. And if you're probably just changing from you the values or changing the position of the subject and what I ask from you. Yeah, I will do it today, so that you can take a look at them. If you're comfortable, we good? So Wednesday is the exam. We'll have 50 minutes. Good luck.